So looking at the back side, there's several different identities, and we're going to use these formulas to find angles that are not on the unit circle. All right, so some angles, not all angles, we can find the exact value, not using a calculator, with the unit circle in these formulas. Okay, so let's look at this first one here. So this is the sum formulas, and these are your difference formulas. So we use these two formulas, and if you want to write notes on the pink paper, even though you won't get to use it, it'll just be notes to help you. You won't get to use that paper. I'm going to make a copy of that side and attach it to the test. So if you're trying to find two angles, if there's an angle on your, that you're trying to find that's not on the unit circle, we're going to figure out, well, what would those different values be by adding? So there's two different angles. Let me go ahead and zoom in. We have alpha plus beta for cosine and sine. Alpha is generally the bigger angle, and beta is the smaller angle. And then we also have, when we find our difference. So for the difference, order does matter. Alpha should be your larger angle, and beta should be smaller. But when we think about addition, order doesn't matter. So 5 plus 2 is the same as 2 plus 5. So it doesn't matter which one you make alpha and beta for the sum. But it does matter for the difference. All right, so go ahead and copy down this first example. Example 1, we're going to find the exact value of 75 degrees. So it's 75 degrees on the unit circle. So it's 75 degrees, an angle on the unit circle. All right, so we can do this using sum or difference. And we'll start off with sum. What two angles on the unit circle can we add together to get to 75? So looking at your unit circle. Well, what did you say, Nathan?
45 and 30.
All right, do you agree with Nathan that 45 plus 30 is 75? All right, so we're going to break this apart then. So we're going to have the cosine. First of all, we're using the cosine sum formula. So let me start by writing that formula down. So cosine sum, does everybody see it right here? Cosine sum is this first one right here. Go ahead and write this down. Write that identity down. And again, it's on your pink sheet. So when you look at your pink sheet, cosine sum says the cosine of alpha plus beta equals the cosine of alpha times the cosine of beta minus, what does it say next on the identity sheet? Sine of what? Of the alpha sine of beta. Now again, when you're using this identity, generally, and I don't know, maybe just to be consistent, we'll just be consistent. We'll always say alpha is the larger angle. Beta is the smaller angle. Okay, so alpha, because we're going to break this 75 down to the cosine of 45 plus 30. And that's what we're using. So we'll say alpha is 45 and beta is 30. Okay, so let's go ahead and fill it in. So I have the cosine of 45 plus 30 equals the cosine of alpha, which is 45, times the cosine of 30 minus the sine of 45 times the sine of 30. All right, and these are all numbers from your unit circle. So go to your unit circle. And tell me these 4 values. So looking at your unit circle, what's the cosine of 45? What's the cosine of 30? And then take the sine of 45 and the sine of 30. So take a minute and find those 4 values from your unit circle. Okay, so now you're substituting those in. So we have the cosine of 45, which is root 2 over 2, and the cosine of 30, which is, wait, yeah, did I say root 2 over 2? So we got root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. So we're going to follow our PEMDAS rules, which means we multiply first. So let's start off by multiplying these two together. And what are the rules for multiplication? How do you multiply? Straight across. And remember, you can multiply square roots, even though they're different. Now, you can't add root 2 plus root 3, but you can multiply root 2 times root 3. We just multiply what's underneath the square root. So 2 times 3 would be, so we would have root 6, and then what's 2 times 2? 4. Minus, and then we have root 2 times 1, which is root 2 over 4. And we have a common denominator, so we can just write this as a single fraction. And that would be your final answer. Now, sometimes when you're doing these formulas, there is more than one way to get to the answer, and you get the same answer. Now, this will not necessarily, because the only things we can add would be 30 and 45. But we could probably subtract something. What could we subtract to get 75? Can we subtract something to get 75? 120 minus 45? I think 120 minus 45 is 75. So anyway, there's more than one option is what I'm trying to say. All right, let's go ahead and look at our next one. All right, we got radians this time. Radians are a little trickier because it's a fraction and we don't like fractions. But 1 over 12 is a really small number, so we will be using a cosine difference. So let's see, you got to figure out what 2 angles are we subtracting to get to 1 over 12. So when I'm looking at this, I think, okay, I got 112. So I know I could do 3 over 12 minus 2 over 12. Or I could do 4 over 12 minus 3 over 12. Keep in mind that 3 over 12 is the same as what? What does that reduce down to? 1/4. So this is pi over 4. Is pi over 4 on our unit circle? Yeah. What is 2 over 12 reduced down to? Yep. Is that on our unit circle? So we got this option. We could either do pi over 4 minus pi over 6. That's my first option. Or I could do pi over 3 minus pi over 4. And what I want to make sure you understand is when you do this on the test, we're going to get the same answer. It's the same thing. So it doesn't matter if we use the first pair or the second pair. The main thing is we need to make sure we get down to 1/12. It's hot, ain't it? I know. It's hot. All right, so I'm going to do pi over 4 minus pi over 6. So let's go ahead and do that. So we're going to use because they're still using cosine. So I'm using the cosine difference. So I'm going to take the cosine of pi over 4 minus pi over 6. So let's look at your formula. The cosine difference, let me go back. All right, that would be this formula here. It's that first one. Alpha is pi over 4 and beta is pi over 6. So we got cosine of pi over 4 times the cosine of pi over 6 plus the sine of pi over 4 times the sine of pi over 6. All right, go to your unit circle and find those 4 numbers. Find the cosine, pi over 4, cosine of pi over 6, and this addition, which is kind of, if you look at it, it's little, because cosine we subtract for the sum formula and we add for the difference formula in the actual identity itself. So let's take a minute, fill in our 4 angles. All right, so root 2 over 2 times root 3 over 2. Who had that for the first pair? And then root 2 over 2 times 1/2. So this is very similar to the one we just did, except this one has addition. So that would be root 6 over 4 plus root 2 over 4, which simplifies to 1 fraction. We already have a common denominator. And that would be your final answer. Can you look in that bucket and see if we have a homework 10 in that? I think that's where we are now. Okay. So now let's talk about, when we look at this one, these are really, really simple to do. We just have to figure out what identity we're using. So what identity has cosine, cosine minus sine, sine? Yeah. Mr. Suchi is passing out homework 10, which is over sum and difference. And I'm not quite sure when it's due. I'll have to check Canvas and let you know. All right, so looking at your four identities, we have cosine, cosine minus sine, sine. Which one is cosine, cosine minus sine, sine? Cosine, is that the difference or is that the sum? It's the sum. So we're just simply adding. This is the cosine sum identity. So that means we just, what this is asking for is the cosine of 70 plus 20, which is simply the cosine of 90. Go ahead, look at your unit circle. Tell me the cosine at 90 degrees. So, and then I know it couldn't be 70 minus 20, right? Because it's 50 on our unit circle. No, right? It has to be 70 plus 20. It's really the only option. So what is the cosine at 90 degrees? 0. So that would be your final answer. All right, let's go ahead and copy down our next example. We got 7 pi over 12. And again, just like you saw me do with the last one, I just start, okay, I know if I'm trying to get 7, I could do 1 plus 6. This is what I do. Like, I just keep trying to change my numerator until I get something that simplifies down to what's on the unit circle. Like, I know that 1/12, do we have 1 over 12 on our unit circle? So we can't use that. Now, we do have 1 over 6, but do we have 5 over 12? Nope. Has to be this. This is one option. 3 over 12 reduces down to pi over 4, and 4 over 12 reduces to pi over 3. So that's the way I look at a fraction. I just look at my numerator and I split it up until I find 2 that will reduce to what we have on the unit circle. So I'm going to use 3 pi over 12, which reduces down to 1/4, and 4 pi over 12. All right, so let's go ahead and do that. So we have to use our sine sum formula. So the sine of pi over 4 plus pi over 3. And when you look at your identity sheet, it's in the first column, but it's the second row. Does everyone see that? Now we're doing sine sum, not cosine sum, but sine sum. So for the sine sum, that says take, so this first one is alpha and the second angle is beta. That says take the sine of pi over 4 and multiply that by the cosine of pi over 3 so alpha is my bigger angle, beta is my smaller angle. And then what does it say do next? Add or subtract? Oh, we're looking for a sign. Look for a sign, the sign sum, not cosine sum. So, because we switched trig identity. So now we're doing sign sum. So now we add. And then what comes next? Cosine of what? Cosine of pi over 4 times the sine of pi over 3. I'm running out of space. All right, go ahead, find those 4 values, finish it out. I do think the hardest part is finding your angles that you're going to use.
Why is pi over 4 but then pi over 3?
You are right. Pi over 4 would technically be the beta. Would be the alpha because that's 60 and 45. You're right. Now for this one, I'm not going to change it. We can, but the only difference is that for difference or for sum, the order doesn't matter. Because when you add 5 plus 2, is 5 plus 2 the same as 2 plus 5? Mm-hmm. So in this example, even though I put them in the wrong order, I have 45 plus 60. Well, is 45 plus 60 the same as 60 plus 45? Do you get the same thing? So alpha and beta only really matters for subtraction. But thank you, Diana. That's a really good point. Okay. So we got root 2 over 2. And then the cosine. What's the cosine of pi over 3? 1/2. And then the sine of pi over 3. And if you look at it, you're probably like, all of these look the same. They're pretty similar, at least for this identity. The sum and difference is pretty similar. All of our answers are pretty close. And the reason why, like if you were to, on your calculator, if you were to type that in, which is why you don't get to use calculators. Because if you type in on the calculator sine, and this is what, 100, what is this? 60, this is 105. It'll tell you the answer. It'll say that it's negative root 6 plus root 2 over 4, which is why you cannot use the calculator for the first couple chapters. But we're almost finished with our unit circle. Chapter 8, I don't remember what it's about, but it's on our homepage. But we'll be moving away. We'll still be doing geometry, but not the unit circle. So that'll be good. Okay, so we end up with root 2 over 4 plus root 6 over 4, which can be brought together into one fraction, and that would be your final answer. Who had that? All right, any questions about how we're working through using, so we're just practicing using these identities. Now, as always, we have learned that tangent is the ugly cousin. It's always complicated. Tangent is a lot. But sine and cosine is pretty simple. All right, I'm going to give you a couple of minutes. I want you to try to find this one by yourself. The sine of pi over 12.
And homework 10 is due Wednesday, March 6th. So you guys know.
Okay.
It's passed down, it's due on Wednesday.
Okay, do this Wednesday. I might move it to Thursday since we just, no, actually, we'll keep it Wednesday. What angles are you using? Let's start off with that. For pi over 12, what two angles? Wait, just thumbs up if you found two angles. All right, I'll let you all keep looking. That's a hard thing. Write down the two angles and I'll look and see if I agree with the ones you're going to use. There's two different pairs. Well, more than two, but...
How do we tell if some are different?
That's a good question. So if you think about it, 1 over 12 is a really small fraction. So there's really no way we can add two that can work two. But you know, if you're not sure, try both. See if you can add. I mean, to get 1 in the numerator, I mean, it would be what, 0 plus 1, I guess. So it would have to be subtraction. So we would have to, you know, subtract something. But that's a good question. Anybody got the angles yet? You do. You got the angles. You got 4 over 12 minus 3. So 8 over 12 is 2 and 9. So you're gonna do 9 over 12, which is 15. Oh, okay, sorry. So you're gonna do 3 pi over 4 minus 2 pi over 3. Okay. Which two would be? Yeah. I saw some really good ones that I didn't even think about. Because I always kind of stick to the first quadrant. But somebody is doing, and again, there's a lot of different options. So when you're doing this on the test, you could pick 2 totally different angles from anybody else and still be right. But I did notice that someone is using 9 minus 8. Which would reduce down to 3 pi over 4 minus 2 pi over 3. So somebody's using that. And then I saw someone else doing 4 minus 3, which would be pi over 3 minus pi over 4. Now remember, when you're doing a difference, order does matter. Okay, because if you subtract 5 minus 2, you don't get the same thing as 2 minus 5. So you really do need to be careful with alpha and beta for difference. And then somebody else I think I saw was doing 3 minus 2. So I saw a lot of different options here. And I want to make sure that all 3 of these people are right. They're all right. And there's more options we could keep going. So keep working to finish it out. We are going to have a skills check over verifying and simplifying identities on Wednesday. So just kind of putting that out there too, so we can all practice before the quiz. I think that because that side is really, there is no notes for that. You just have to practice. It's really just, so we'll do a 1-question skills check on Wednesday for verifying. It'll be a verify or a simplify. I'm not sure which one yet. So. Okay, so who had this as their answer? Now, you could have also ended up with, it could have said negative root 2 plus root 6 over 4. Either one of those would be right. So I'll give you a minute to look at that. Compare your answers. Who had that? All right, so we're going to end there. Use this time to start working on your homework. Tomorrow we'll do tangent sum difference, because tangent sum difference, tangent takes a lot of work. So for right now, you can skip over numbers 3 and 5, and we'll come back to 3 and 5. We'll talk about those tomorrow.